Andrew. Very interesting question here, sir. We have two functions. We have f of x and g of x. Okay. Let's take a look, sir, at what we have to find. We have to find g of 1, part A here, okay? So let's evaluate g of 1. So function notation tells us that we're going to use this function, g of 1, and wherever there's an x, we're going to sub that in. So that's going to be 3 times 1 minus 5. Therefore, g of 1 is going to equal 3 times 1 is 3 minus 5 is negative 2. So that's our answer. Okay, so that's part A done. But then what part B is going to ask us, which is probably where your question comes from, is what's f of g of 1? Okay, so let me try and use colors here. Yellow is g of x, alright? So we're evaluating all this stuff. Here's g of 1, which we found to be negative 2. So what we're going to have to do, f of g of 1 is like saying find f of negative 2. Because up here we've already kind of defined g of 1 equals negative 2. So I'm going to replace g of 1 in my notation with negative 2. And that's all this is. This is just notation. This is not, a real equation, so to speak. I'm not trying to solve for anything or get crazy like that. I'm just trying to evaluate g of 1, which I did. Now I'm going to sub that in, and we're going to find basically f of negative 2. What I'm going to do is I'm going to take this function and I'm going to sub in negative 2 for x. So it's going to be negative 2, use brackets, squared, minus negative 2, use brackets, watch your negatives, plus 2. And now we'll just evaluate this. So negative 2 is 4, plus plus, so that's going to be plus 2, plus 2. 4 plus 2 plus 2 equals 8. So there's our answer right there. Okay, so I hope that helps, and this is actually something that we're going to talk about coming up soon, composite functions. So what that means is we have two functions, and the output, or the answer, of one function becomes the input, or what we sub into, of the next function. Very interesting. But there it is. I hope that helps. Let me know if it doesn't.